Concentrations of solutions, molarity. If our iced tea does not taste sweet enough, we add sugar to it. This means we are increasing the amount of sugar in the drink. From the point of view of a chemist, the concentration of a solution tells us of the amount of the solute dissolved in a known volume of a solvent. For example, more intensely colored solution contains more amounts of solute dissolved in it. As a majority of chemical reactions carried out in the laboratories are in solutions, it is important to understand the different ways of expressing their concentration. There are a number of ways of expressing the concentration of a solution. In this topic, let us understand the most commonly used concentration unit, that is, molarity. As we all know, mole is the SI unit of amount of a substance. 6.023 multiplied by 10 to the power 23 particles are present in 1 mole of any substance. The mass of this 1 mole of a substance, when expressed in grams, is called its molar mass. The number of moles of a solute present in a given solution can be determined by dividing the mass of the solute by its molar mass. The number of moles of a solute present in 1 liter of solution is called its molarity. It is expressed in mole per liter, or mole per cubic decimeter, and is denoted by an uppercase M. Let us prepare 0.1 molar nickel chloride solution to understand the concept. For this, we need to weigh exactly 0.1 moles of NiCl2, which is equal to the product of the molar mass of NiCl2 and 0.1. This is equal to 12.96 grams. Now transfer this accurately weighed NiCl2 into a 1 liter standard flask. Add a small amount of distilled water to it. Swirl the flask gently to dissolve the solute in water. Then fill the remaining flask with distilled water exactly to a 1 liter mark. The solution now contains 0.1 moles of NiCl2 dissolved in 1 liter of the solution. Thus, the prepared solution is 0.1 molar nickel chloride solution. Remember here that the solute is dissolved in 1 liter of solution and not in 1 liter of solvent. Now, let's transfer this solution to 4 other standard flasks with different capacities. This means we are transferring 0.05 moles, 0.025, 0.01, and 0.005 moles of NiCl2 to the respective flasks. Although the number of moles of NiCl2 solute present in each of these solutions is different, as the volume of each flask is different, the concentration of all these solutions remains the same, that is, 0.1 molar. Now, let us transfer the contents of 50 milliliter standard flask into a clean, empty 100 milliliter standard flask. At a molecular level, this means we are transferring 0.005 moles of NiCl2 into a 100 milliliter standard flask. Dilute the solution up to 100 milliliters using distilled water. The resulting solution will now have 0.005 moles of NiCl2 present in 100 milliliters. The molarity of the solution will be 0.05 molar. This implies that dilution reduces the number of moles of the solute per unit volume. However, the total number of moles present in 50 milliliters and the newly prepared 100 milliliters NiCl2 solution remains unchanged. Using this fact, we can prepare a solution of lower concentration with the help of a solution of higher concentration using the formula the product of molarity and volume of the concentrated solution is equal to the product of molarity and volume of the diluted solution. Summary: molarity is a way of expressing the concentration of a solution. It is the number of moles of solute dissolved per liter of solution. A solution containing 12.96 grams of NiCl2 per liter of the solution is 0.1 molar, as it contains 0.1 moles of NiCl2 in 1 liter of solution. A solution of lower molarity can be prepared by diluting a solution of higher molarity.